Okay, this is from the mock exam, free response question 1. We were given the velocity, and if you're watching this tonight, I know we didn't learn velocity yet, but we're learning it tomorrow, so you'll be able to understand this after tomorrow. Okay, so this is the velocity, and you're asked to find the acceleration at t equals 5.1. So the acceleration is just the derivative of velocity, so we're going to use a of t for acceleration, and this is just going to be a quotient rule. So it's going to be, I'm going to do it over here because I'm going to need more room. It's going to be the bottom, I'm trying to write small, times the derivative of the top, minus the top, times the derivative of the bottom, all over the bottom squared. Okay, so you're supposed to find the acceleration at 5.1. So question number 1 is a calculator question. So what I would recommend is, you're not going to try and simplify all this. I would say put all this into your y equals. Be really careful with your parentheses. So for example, you're going to need one big set of parentheses as a numerator. And then you're going to end up needing one big parentheses for the denominator. And then you're going to need another set of parentheses for your first term, and then another one here and here. Okay, so you can do that, or you could rewrite the whole thing. You know, I'm not going to do the whole thing, but you would do it like this: 10 times 5.1 to the third plus 3 times, and then you would do it like that, and then you can do it piece by piece, whatever you feel most comfortable with. And this will certainly drive you crazy, but you should get the answer, which is 6.4918. Okay, and that was worth 1 point. Now there's actually an easier way to do that, but this is the way. If you know it best, you can do that. You do have 15 minutes for the free response. Okay, another way to do this is, do you remember when we had, let me just get another color. Okay, do you remember when we had something like f of x equals blah blah blah, find f prime of 3, and then I showed you on the calculator how you can go to, I think it's math 8, it says n deriv. Just look and see if that's math 8. And then you would put in the function at the point, and it can give you the derivative. Well, if you need to know the acceleration at 5.1, that would just end up being the derivative of this at 5.1. So you would go into your calculator, and you would, and you could have the calculator do all the work for you. Okay, so you would go into your math 8, it's going to say n deriv, and then, I don't know, depending on which calculator you have, so let's say you have the older one, you're going to be putting in the t to the 6, you do your numerator, divided by the denominator, and then you have to declare your variable. Well, you're going to be putting this as x, and then you're going to write at 5.1, and that will also give you 6.4918. Also worth 1 point, no matter which way you do it. But I feel like you'll use a lot of time the other way. Okay, so you have to keep in mind that if it's a calculator question and something is taking extremely long, they're assuming you're doing it on the calculator. So you can't say you didn't give me enough time, because they're going to say, well, you had a calculator, you should have used the calculator. Okay, so that was part A. Now we're going to move on to part B. Okay, so for part B, we're told we're just talking about the interval from 0 to 2, and we want to know, when is the speed of the particle equal to 1? So the thing that you need to know is that velocity is the same thing as speed, except speed is always positive. Velocity tells you about the speed and the direction, while speed just tells you the speed, okay? So we already know that the velocity is this, right? They gave you this. Okay, so speed is just this, the absolute value of velocity. So we're interested in when does that equal 1? So you're going to subtract 1 from both sides, and when you do, you'll get this, right? 0 on the other side. So then you're going to put this into your calculator under your y equals. So if you're unfamiliar on how to do absolute value, you can go to, I believe it's second and then catalog, that button, and then it's the first thing, it's going to say ABS. That's the one you want. So you're going to choose absolute value, and then you're going to put this piece in, close the absolute value, close the parentheses, and then do -1. Set your window from 0 to 2, and then you're going to do second calc and 0 to see where it is at the x-axis, and it should hit it at 2 places. We'll hit it at 0.771829, and it will hit it at 1.400556. Okay, so what were the point values for this? If you just, here, let me erase this so I can show you. Okay, if you just did this absolute value thing and set it equal to 1, that was worth 1 point. And if you got these two solutions, that was worth 1 point. So that's 3 points so far for this question. Okay, this is part C now, and they're asking you, find the position of the particle at t equals 4. That means, like if you're looking at a coordinate grid, what's the y value? Like where are you at t equals 4? So you're going to need to know how far you traveled, going from 0 to 4 of your velocity. But you have to know where you were at the starting point. So they gave you at the very beginning that at t equals 0, the particle is at 7. So you started at 7, so you have to add the 7. If they had said, like it was at 4, at t equals 0, then you do 4 plus this thing. Okay, so this is going to be 7 plus, then you're going to use your calculator for this part because you know what v of t is, and you should get a negative 0.2884415. Combine those and you get this. Okay, and the point values were extremely generous for this one. So if you just had the 7, that was equal to 1 point. If you just had this integral, that was equal to 1 point. And if you got the answer, you got 1 point. So I think that was pretty generous for that. Now there was a second part to this question, which says, is the particle moving toward the origin or away from the origin? Okay, so when they're talking about the origin, they're thinking of like a number line, and here's 0. So is the particle going in a positive direction, or is it going in a negative direction? So what is happening at t equals 4? So you on your v of t function, you're going to do v of 4. And when you do v of 4, you're going to get a number bigger than 0, a positive number. And therefore, the particle is moving away from the origin. It's going in this direction, right? Because the velocity is positive. So if the velocity is positive, it's going to the right. Okay? But they didn't even ask that. They just asked, is it moving toward the origin or away from the origin? And so the answer would be the particle is moving away from the origin, and that is worth 1 point for that. So that was pretty good. Okay, and this is now part D, and it is asking you, during 0 to 4, will the particle ever return to its initial condition? Give a reason for your answer. Okay, So here's what you would have to say. The initial position at t equals 0 is x equals 7. Okay, so it's at 7. So you're thinking of a number line and it's at 7, okay, at time t equals 0. At t equals 4, it's at 6.711558. Remember, that's what we just got from the previous question. So so you can try all different, whatever values you want. I tried t equals 1 because you're going to go from 0 to something, so I'm going to try t equals 1. At t equals 1, it's at the integral going from 0 to 1 of v of t dt plus that's 7 where you started. And you're going to use your calculator and it's going to say 9.4035. Okay, I could keep going. Okay, so let's see what happened. So I'm going to make some room up here. Okay, so this is your final statement. It started at 7, went to 9.4035, went to 6.711558. So think of a number line. I mean, you wouldn't do this on the test, but I mean, you could. I mean, they're not going to take anything off, but I'm just saying for your own visual. Here's a number line. Let's say here's 0. So here it is, and it's at 7. Here's the particle. It went to 9.4, right? So it went this way. That was at 1 second. But after 4 seconds, it was at 6.7. So then it went back this way. How can you go from 9.4 to 6.7 without passing 7? It would be impossible. So we would say it started at 7, went to 9.4035, went to 6.71158 by the intermediate value theorem. It must have gone, must have gone through 7. And that's how they're going to sneak the intermediate value theorem in. So I'm at 13 minutes, and I think that's pretty good because I did a lot of talking, and you would have had 15 minutes for that problem. Okay, that completes number 1. Oh wait, let me give you the point values. Do I have those point values? Hang on. Okay, the point values would have been 2 points for this. So definitely, okay, I don't have the exact thing here of how you got those points, but I think it is very safe to assume that by saying the mean value theorem, that is 1 point, and then this other information, I'm sure that's how it went, is worth another point. Okay, now we're finished with 1.